Assume you've been asked to write down 3 multiplied by 3. Remember, you haven't been asked to calculate it. So you pick up your pen and write it as 3 times 3. Here we are multiplying 3 by itself just once. Now let's say you've been asked to write down 3 multiplied by 3 multiplied by 3. You write it down as 3 times 3 times 3. In this example, we are multiplying 3 by itself twice. 3 multiplied by itself multiplied by itself. Now you've been asked to write down 3 multiplied by 3 multiplied by 3 and so on 7 times. So now you're kind of bored, but you don't have a choice. So you write 3 times 3 times 3 times 3 and so on 7 times. Yes, I know what you're thinking. The more number of times you multiply a number by itself, the more tedious it gets for you to write it down. So that brings us to the question, is there an easier way to denote these kind of operations? What kind of operations am I talking about here? The ones in which a number is multiplied by itself many number of times. The answer to that question is yes, we do. Which brings us to the topic of exponents. 3 multiplied by 3 can be written as 3 with a 2 in the superscript. This is read as 3 raised to 2. How do we get a 2? It depends on the number of 3's you can see. So we have 2 3's here, and hence we write it as 3 raised to 2. In the second case, we can see 3 3's. Hence, it can be written as 3 raised to 3. How do we get a 3 in the superscript? That's because we have 3 3's. And in the final example, we have 1, 2, 3, 4, 5, 6, 7 3's. So we write this long string of numbers of 7 3's as 3 raised to 7. If we have any number, say a, multiplied by itself many times, we write it as a multiplied by a multiplied by a multiplied by a and so on. If there are n number of a's in this product, then it can be written as a raised to n. The number a is called the base and the number n is called the exponent. In the 3 examples we saw, all of them have a base equal to 3. It is just the exponent that varies. In the first case, the exponent was 2. In the second case, the exponent was 3. And in the final example, the exponent was 7. In the coming videos, we will look at the different properties of exponents. Until now, we have worked only with positive exponents. Here's a very simple example to understand negative exponents. Consider this number 3 raised to minus 4. Since we are familiar with positive exponents, let's understand how we can write this negative exponent as a positive exponent. We multiply and divide the number by 3 raised to 4. Multiplied by 3 raised to 4 and divided by 3 raised to 4. In short, we are multiplying the number by 1, which will keep the original number unchanged. That equals 3 raised to minus 4 multiplied by 3 raised to 4 divided by 3 raised to 4. We multiplied this with this and divided by this. Focus on the numerator now. Since the base is the same, we can use the product law to write it down as 3 raised to minus 4 plus 4. And we write the denominator as is. Minus 4 plus 4 equals 0. Hence, that would equal 3 raised to 0 divided by 3 raised to 4. And since we know that any non-zero number raised to 0 equals 1, we can write it down as 1 divided by 3 raised to 4. Let me repeat. This is a very important property. Any non-zero number raised to 0 equals 1. This was our original number, 3 raised to minus 4. And we got the answer as 1 divided by 3 raised to 4. So all we did is change the sign of the exponent and wrote it under 1. So we can generalize it as a raised to minus m equals 1 divided by a raised to m, where a is not equal to 0. Because if a is equal to 0, then we would have 0 in the denominator, which would make it indeterminate. This term is read as a raised to negative power m. There's a very simple trick we need to understand here. Consider 3 raised to minus 4. When we have to write it down as a positive exponent, it equals 1 divided by 3 raised to 4. So all we did here is change the sign of the exponent and wrote it under 1. Now consider 21 by 37, the whole raised to minus 7. To write it down as a positive exponent, we write it down as 1 divided by 21 by 37, the whole raised to 7. Again, we just changed the sign of the exponent and wrote it under 1. The same trick can be used for positive exponents too. Now consider 4 raised to 3. We can write it down as 1 divided by 4 raised to minus 3. We changed the sign of the exponent and wrote it under 1.